We are going to look at graphing ellipses now. And so here's our problem. It says graph the ellipse with the given equation. First thing I need to do is identify which tab of my flipbook I will be using. And I do that by identifying where my a squared is. And remember, a squared is always the bigger denominator. So my a squared is going to be the 16. Then I look at which variable that's attached to. That's attached to the x squared one. So I'm going to be using the first equation in our flipbook, which looks like this right here. Now, when I'm graphing an ellipse, I want to go through and I want to identify my center, my vertices, my co-vertices, and my foci, and then I'm going to graph each of those. Now, my center, remember my center comes from HK, but I take the opposites of those, and I need to look at what's being added to the x to find my h, and that would be 0. And my k is what's being added or subtracted to the y, and that would be 2, but I need to take the opposite of it, so it would be a -2. So my center is at 0, -2. Then I'm going to look to my vertices. Now, according to my formula for my vertices, it says I take h plus or minus a, comma k. Well, I already know my k is -2, so I'm going to fill that piece in. I have to deal with this h plus or minus a thing. Well, my h, we've already got that established, is 0. The a comes from the denominator. But now remember, this is a squared, so I need to square root both sides, and I get a is equal to 4. So now to find my vertices, I'm going to have to add 4 to my h, which would give me a 4, and I'm going to have to subtract 4 from my h, so I would get a -4. So my vertices are at 4, -2, and then -4, -2. Then my co-vertices. Look at my formula for that, and it says I have h, comma, and then I have to do k plus and minus b. Well, my k comes from my vertice, it's -2, but now I have to figure out what my b is. In the b is the other denominator, but remember it's b squared that is equal to that denominator, so I have to square root both sides, and in this case, b is equal to the square root of 10. So I would have -2 plus the square root of 10, and -2 minus the square root of 10. Now when we're graphing, we actually need to get a decimal approximation for those because we need to be able to plot it on our graph. So when you type that in, the -2 plus the square root of 10, you get about 1.16. And then when you do the other one, the -2 minus the square root of 10, you get about -5.16. And then the last thing I need to find are my two focus. And according to my formula, I have to take h plus and minus c, comma k. So again, my k is going to stay as a -2, but I'm going to have to find this value for c in order to figure out what my x-coordinate is going to be for my focus. Well, now remember, for c, we know that c squared is equal to a squared minus b squared. Well, I go back to my a. My a is 4, so 4 squared is 16. My b is the square root of 10, so square root of 10 squared is 10. So I end up getting c squared is equal to 6. So c is equal to the square root of 6. Now I'm going to plug that into my formula, that h plus c. Well, my h is 0, so 0 plus the square root of 6 would be the square root of 6. Again, though, we need the decimal for that so we can plot it, and it's about 2.4. And then I need to do the other one, 0 minus the square root of 6. That's about -2.4 for this particular one. Once I have all my important points here found, I need to start by plotting the first 3 of them. So I'm going to plot my center at 0, -2. Then I'm going to plot both of my vertices. Then I'm going to plot both of my co-vertices. And the last thing I need to plot are my focus points. And because we have to plot all of these points, that's the reason we needed to change them into decimals. Once I get my points plotted, now I'm going to sketch in my ellipse. Try to make it a nice smooth curve. Should be an oval type shape. That looks like that. Now notice the ellipse does not go through the two focus. Those are just reference points of our ellipse. The ellipse is actually only through the vertices and the co-vertices. Another type of problem that you're going to be looking at is writing equations of the ellipse based off of some given information. So here's the problem we're going to look at. We know our vertices are going to be at 0, 8, and 0, negative 12, and the focus is at 0, negative 8. First thing I have to do is I have to decide which equation am I going to use. And to do that, I'm going to just compare my vertices. And from my vertices, I know that my x value doesn't change. So as I go through and I look from my vertices, I want to look at which one has the equation of h just staying h. Once you look at that, hopefully you'll notice that it's the second one on our flip book. So we're going to be using the equation y minus k squared divided by a squared plus x minus h squared over b squared is equal to 1. Okay, as I look at the equation for my vertices, this particular formula is the one that gives me h comma k plus a and h comma k minus a. Now I can also do a double check by looking at my focus, and for this particular set of equations it says my focus is h comma k plus and minus c. So it follows that a or h remains the same throughout each one of these. So I'm sure that I am on the right set of equations. Now what I need to do is I need to start identifying what pieces of information do I have. I need to figure out what h, k, a, b, and c are. Well, I can tell right away that my h is equal to 0. That part is taken care of right there, and right there, and right there. Those two are equivalent. The next thing I can tell from my vertex is that k plus a is equal to 8, and then k minus a is equal to negative 12. Now you might be wondering, how did I know that the plus 1 went with the 8 and the minus 1 went with the negative 12? It actually doesn't matter once we get through to the final answer. So if you had k minus a was equal to 8 and k plus a was equal to negative 12, you would still end up with the exact same final answer that we're going to get. And that kind of comes into play right now with the focus. My focus, I know that it's either k plus c or k minus c that has to be my negative 8, and it's not going to end up mattering which one you take. So I'm just going to do k plus c is equal to negative 8. Now, if I try to solve this k plus a equals 8, I've got a problem because I have two variables. Well, so let me go to the next one, see if that one helps me. It says k minus a equals negative 12, still two variables. So if I jump to the focus to try that one to see if I can find another piece of information, k plus c is equal to negative 8, still two variables. And I don't have any of those variables. I don't know the values of any of them. I only know what h is. So at this point what you need to realize is that these two equations right here, k plus a and k minus a, we need to bring those two together into a system. A system of two equations that has two variables is solvable. Okay, once I get these two set up in a system, I've got to make sure that I have one variable have the same coefficient but opposite signs, and I already have that with the a's, so I don't need to multiply the top or the bottom by anything, and I'm going to add my two equations. So 1k plus 1k is 2k, a plus a negative a is 0, and 8 plus a negative 12 is negative 4. Divide both sides by 2, and I now have a value that k is equal to negative 2. When I come back and I plug that in, I'm going to have negative 2 plus a is equal to 8. Add 2 to both sides, and I get a is equal to 10. I would have gotten that same thing over here if I plugged it into this equation. I would have ended up with negative a is equal to negative 10, so a would be equal to 10. So far, I've added to my list. I now know that k is equal to negative 2. I know that a is equal to 10, and according to my formula, I need a k, an a, an h, and a b. So the only thing I'm missing right now is the b. Well, It doesn't look like I have a b in any of my formulas, but you've got to remember that b is related to my a into this c value over here. So I'm going to go in on this focus problem, I'm going to solve it for c. Well, my k we just found to be -2, so I know -2 plus c has to be equal to -8. Add 2 to both sides and we get c is equal to -6. Well, we have that formula that relates a, b, and c together, and that tells me that c squared is equal to a squared minus b squared. Well, what is -6 squared? That's a positive 36, and this is the reason that it didn't matter if you picked k plus c or k minus c. If you picked k minus c, you would have gotten c to be equal to positive 6. Well, a positive 6 squared is still a 36. So that's why it didn't matter which way we picked it. Then my a squared, I got a to be 10. Well, 10 squared is 100. Subtract the 100 from both sides. Divide both sides by -1. And then in order to get rid of that square, I have to square root. So b is the square root of 44. Now when I go back to write my equation, I've got to use the pieces of information that I need here and plug them into my formula up here. So I'm going to start with y, and then my k is -2, but remember I always want to do the opposite, so I would do y plus 2, quantity squared, divided by a squared. Well, my a is 10. 10 squared is 100. Plus, I have to do my x part in x minus h. Well, my h is 0, so I'm just going to have an x squared. And then it says over b squared. Well, the square root of 44 squared is just 44. And that's equal to 1. And that would be my equation based off of knowing the vertices and the focus. You can do that with any information. It doesn't just have to be the vertices and the focus. It could have the co-vertices in there. But it's the exact same process. You always want to go through and first figure out what are my formulas, or what equation am I using first, what formulas relate to my pieces of information, and then how are they related. Like for this one, we ended up having to make a system because I ended up with too many variables. So it's going to follow a similar process. Sometimes you'll need a system, sometimes you won't. But keep that in mind, it all comes down to the formulas that you have in your flip book.